Okay, so it's getting late. I just got done doing your video on how the lesson for similar solids, and so I may not be able to get much on this one done, but I wanted to go ahead and do a couple problems and give you guys a chance to look at this. So the first question says, are the two figures similar? So we talked about similar earlier in the year, and we said two things had to be true. The angles, angles have to be congruent, and the sides have to be proportional. Okay, so the angles have to be congruent and the sides have to be proportional. Well, we can't see the angles here, so we're going to have to assume that these are both rectangular prisms. So the question is, are the sides proportional? So does 12 scale up to 40, the same that 24 scales up to 80, and 18 scales up to 60. So let's find out, what does 12 feet over 40 feet reduce to? You can set it up in this scenario here and say, how about 24 feet over 80 feet and 18 feet over 60 feet? Because if we said if things are proportional, we should be able to set them up in a proportion like this and it be true. Well, look, 4 goes into 12 3 times. 4 goes into 40 10 times. 4 goes into 24. Let's see, actually 8. 8 goes into 24 3 times. 8 goes into 80 10 times. Looking good so far. What goes into 18? 6 goes into 18 3 times, and 6 goes into 60 10 times. So yeah, this is true. 3 and the feet reduce, the feet and the feet reduce, the feet and the feet reduce. So 3/10 equals 3/10, which is equal to 3/10. This looks good. These are similar. So you say, yes, they are similar. And the scale factor, K, you have to be careful about what the scale factor is, okay? It really depends on which way you're going, whether you're going from small to large. So we're just going to say K is equal to 3/10. 3/10 would actually be from the large going to the small. So if we go from the large to the small, we're going to use a K of 3/10, okay? And that's totally fine as long as we defined it. K equals 3/10 from large to small. And you can do the same thing with the rest of these. Set up your proportions and find out if those proportions are equal. So number 5, each pair of figures is similar. They are similar, so they've told us they're similar. Use the information given to find the scale factor from the figure on the left to the figure on the right. So we're going to go from this one to the second one. So we've got the surface area of 396 to the surface area of 275. Okay? So what I want to do is I want to say, look, there is some scale factor. If I go from the left, I need to multiply that by some scale factor K to get me to the right. However, in this case, our K, so we can say K is equal to R over L. Okay, so right over left, the right's going to go on top. So basically your after will be on top and your before is going to be on bottom. K is going to equal to R over L. But in this case, we're talking about surface area, which we talked about in the video is two-dimensional. And that means we're going to need a two-dimensional K, or K squared. So here's what we're going to have to set up. We're going to have to say, look, this R over L factor that is K, the right over the left factor, needs to be squared in order to match the R over L surface areas that we have here. So the surface area of the right should go on top at 275 centimeters squared over the bottom, which is 396 centimeters squared. And notice they're already squared because it's area, and that is a two-dimensional measurement. So the question is, okay, what is K? So this R over L was K. So I can say, look, k squared equals, and centimeter squared over centimeter squared is going to reduce. And I'm going to put this in my calculator. 275, turn it on. 275 divided by 396 equals, well, that reduces to 25 over 36. 25 over 36. And hey, how do I get rid of a square on this k? Well, I take the square root of both sides. Square root of both sides. And since these are measurements in geometry, we don't have to worry about the negative. We're only going to worry about the positive root here. So k is equal to 5, which is the square root of over 6, which is the square root of 36. And you can do that same thing for the rest of these. And I apologize that I've got to take off, but hopefully that'll give you enough to play with these similar figures and see if you can try to find the scale factors between each one. Remember, as a note, I probably should have started with this, we've talked about before that scale factors bigger than 1 are an enlargement. The object should get larger. And a scale factor where it's between 0 and 1, that's what this means. 0 is less than k, and k is less than 1, so it's between 0 and 1. Scale factors that are between those are a reduction. They get smaller. Okay, so that's how I knew that this had to be a scale factor of 3/10 had to be from the large to the small, because that's the only way I would have gotten 3/10. That is a reduction. Have a good weekend.